In Lesson 8.2, we are going to start our discussion on trigonometry. And trigonometry comes from two Greek terms, trigon, meaning triangle, and metron, meaning measure. So the study of trigonometry involves triangle measurement. If you look at the diagram in the middle of your page, we have three triangles, and I can see that I have right triangles and they all have a 32-degree angle. So all three of these triangles would be similar by the angle-angle shortcut. Now, if I were to compare the short side to the hypotenuse, and the short side to the hypotenuse, and the short side to the hypotenuse, because those triangles are similar, all of those comparisons or all of those ratios would be equal. Agreed? Well, that's kind of what we're going to talk about today. We're going to talk about the trigonometric ratios, ratios that are true for right triangles. So a trigonometric ratio, by definition, it's the ratio of the length of two sides of a right triangle. We are going to work with 3 of the 6 trigonometric ratios, and those 3 in here, sine, cosine, and tangent. Okay. Well, the sine of an angle is the ratio of the length of the leg opposite the angle to the length of the hypotenuse. Well, if you look at my triangle over here, triangle ABC, we have the angles labeled with capital letters, and my sides are labeled with the lowercase letters. You'll notice that angle A and side A are across from each other. Angle B and side B across, and so on. And we're always going to set up or view our triangles like that. The definition for our sine ratio says that it's the length of the opposite leg over the length of the hypotenuse. So my sine of angle A, well, from angle A, the opposite side across from it would be side A, and my hypotenuse would be C. So this ratio would be given A over C. Now we know that in our triangles and our examples, we're going to be working with numbers. The cosine of an angle is the ratio of the length of the leg adjacent to the angle to the length of the hypotenuse. So the cosine of angle A, again here angle A, it is defined as the adjacent leg over the hypotenuse. Well, from angle A, the leg that would be adjacent is right here, and that was going to be leg or side B, and my hypotenuse as side C. Your hypotenuse will never be considered the leg that's opposite or adjacent. It will only and always be the hypotenuse. And lastly, the tangent of an angle is the ratio of the length of the leg opposite the angle to the length of the leg adjacent to the angle. So my tangent of angle A, I'm looking for the opposite and the adjacent. Opposite over adjacent. Opposite side would be A, adjacent side would be B. So those are how the trigonometric ratios are defined. Now, I'm going to want you to memorize each one of those and what the ratio is, but there's actually kind of a little saying that goes with that to help you. We use the saying SOHCAHTOA to help us remember sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, and tangent, opposite over adjacent. So Krakatoa. Now, keeping in mind these ratios are only true for right triangles. So, let's practice setting some of these ratios up. At the top of page 2, I've kind of put our little reminder to help us remember our trig ratios. Sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, and tangent is opposite over adjacent. Example A asks us to use the triangle to write each ratio as a fraction and as a decimal, rounded to the nearest hundredth. So in the first example, we're looking for the sine of angle T. It's important as to which angle you're working off of. For angle T, my sine ratio tells me opposite over adjacent. Well, from angle T, the opposite side would have to be 12. Sorry, opposite over hypotenuse. And the hypotenuse side would be 20. So this ratio would simply be given as 12 over 20. But I do know that in lowest terms, that would be 3 over 5. As a decimal, well, I know that 3 over 5 is 6 over 10, so it's 6/10. If I wasn't sure, I could divide that on my calculator, 3 divided by 5, and to the nearest hundredth, then I guess technically we would say that would be 0.60. The cosine of angle T, well, cosine is adjacent over hypotenuse. So from angle T, the adjacent side is 16, and the hypotenuse is 20. So my ratio would be 16 to 20. Of course, we're going to reduce that, 4 to 5. And I know 4 out of 5 is 8 out of 10, or 0.8 as a decimal. And lastly, the tangent of angle T. Well, tangent is opposite over adjacent. Again, my opposite side 12, my adjacent side 16. 12 divided by 16, or reduced to 3 over 4. And I know 3/4 is 0.75. So here we're just practicing setting up our ratios, and we're simplifying. Now, it does change a little bit. When they ask for the sine of angle G, well, this time my angle switches. Now, if I think about working off of angle G, the opposite side from angle G, opposite meaning across from, now becomes 16. And my hypotenuse, well, my hypotenuse is going to stay the same. It's always going to be 20. But my sine of angle G is going to be 16 over 20. My cosine of angle G, well, cosine is adjacent over hypotenuse, but to angle G, the adjacent side would be 12. So this is going to be 12 over 20. And tangent, opposite over adjacent, well, from angle G, opposite over adjacent. My opposite side is 16, my adjacent side is 12. And you'll notice here, 4 over 3, as a decimal, we're going to get 1.3 repeating. So there we have just practice setting up our ratios. In example B, we're going to look at those ratios for our special right triangles. And so example B asks us to use a special right triangle to write the cosine of 30 degrees as a fraction. Well, just to give us a little bit of a reminder, let's just sketch our 30, 60, 90 triangle. Our short leg would be 1, then our hypotenuse would be 2, and as we said, our long leg would be 3. Those were the ratios or the side lengths that we worked with in Chapter 5. Now, the cosine of 30 degrees, we know the cosine is the adjacent over the hypotenuse. Well, from my 30-degree angle, adjacent means next to. Well, because we know that 2 has to be my hypotenuse, root 3 is going to have to be my adjacent side. And so as I look to write my fraction, 2 over, adjacent, root 3 over 2. And so as my cosine of 30 degrees, that ratio is root 3 over 2 as a fraction. Now, if it asks me to find that as a decimal, I just go ahead and put that in my calculator. And also, sometimes we do end up having to rationalize our denominator. I know that if I would have a radical on the bottom, I would have to do some simplification there. Number 2, use a special right triangle to write the tangent of 45 degrees as a fraction. Well, in our 45, 45, 90, a review of our ratios, we know that it's isosceles. Our legs are congruent. Our hypotenuse was root 2 times as long. The tangent of 45 degrees, well, tangent, if we look at the top, is opposite over adjacent. My 45 degrees, does it matter which one I pick? No, it actually doesn't. The opposite side, well, if this is my hypotenuse, opposite across from, adjacent next to, either way, I'm going to end up with 1 over 1. So the tangent of 45 degrees is just 1. Now, we actually, our calculators will actually calculate these ratios for us. So if you take your calculator, the first thing is you want to make sure that you are in degree mode. And I can see down here, I'm in degree mode. If you have a graphing calculator, you probably need to switch that by hitting the mode button and going into that menu. But our buttons here, sine, cosine, tangent. We just calculated the tangent of 45 degrees. Well, I could actually put that in my calculator, tangent of 45 degrees, and it tells me it is 1. Or the cosine of 30 degrees, well, 0.866. Well, we had gotten the square root of 3 divided by 2. Well, that is 0.866. Now, we're going to practice calculating those in example C. All you really need to do is just to enter them into your calculator. The cosine of 76 degrees, it's a good idea to close off that parenthesis at the end. And we are going to round them to the nearest hundredth. So the cosine of 76 degrees would be about 0.24. And so here our calculators are equipped to already calculate these ratios for us. Rounded to the nearest hundredth, sine of 8 is 0.14. Now, let's say you didn't have your calculator, but you probably have your phone. Your phone would calculate it as well. The only thing that you have to be careful of is that when you calculate with your phone, it's a little different. You have to hit the number first, and then you have to hit the function. So 82, and then I have to hit tangent. And we do get a little bit of a weird number here. It does come out as 7.12. If I would have hit tangent 82, nothing happens. Because in this case, we have to tell it what number first and then to take tangent. Okay, so why are the trig ratios important? Well, we can actually use them to solve for some missing information in our triangles. In example D, if you take a look, they're asking us to find the missing length. And they're wanting us here to find the length of QR. Well, typically in a right triangle, we would use the Pythagorean theorem, but I don't have enough information here. I only have one side length. Now, I'm going to go ahead and label QR as X. Because we have a right triangle and we do have one angle measure, we can use the trigonometric ratios. Now, as a reminder, the trigonometric ratios, we're going to think about SO, CA, TOA. And as I look at number 1, I'm going to work off of my 63-degree angle here. Well, from angle P, 63 degrees, the 12.9 is my hypotenuse. And I'm actually wanting to find side x, which from angle P is the opposite side. So we're going to look at which ratio would use opposite and hypotenuse. Looking up here, opposite and hypotenuse would be s for the sine function. So I can set this up as so. The sine of 63 degrees equals opposite over hypotenuse, which we're going to say is x over 12.9. Now, we have just done a chapter on proportions, and we can actually kind of think about that this way. If I were to figure out my value for x, and I think about this as a fraction, well, my cross products would tell me that x would be equal to 12.9 times the sine of 63 degrees. And that's exactly how I'm going to calculate it. So I'm going to take my calculator, 12.9 times the sine of 63 degrees. And we would find that to the nearest hundredth, that would be about 11.49. So my side x, about 11.49. Now I will tell you that I could put the sine of 63 first, but I need to remember to close the parenthesis before I put 12.9. If I don't, sine 63 times 12.9, it's wanting to take the sine of that product, and we get something totally different. So we need to be careful with how we enter. Question number 2, we're looking for side ST, and again, I can't use the Pythagorean theorem, but I do have an angle measure here. 9.5, I have my hypotenuse side, and this time, from my 42-degree angle, x would be the adjacent. So I can use the trig ratio that would use adjacent and hypotenuse. As I come up here, adjacent and hypotenuse would be c for cosine. So I'm going to say, well, the cosine of 42 degrees would be equal to the adjacent over hypotenuse. Setting this up the same way, we know that our cross products are going to equal x is equal to 9.5 times the cosine of 42 degrees. So here, 9.5 times the cosine of 42 degrees, and we see it is about 7.06. Okay, last one. Question 3, they are asking me to find side BC. I have my 15-degree angle here that I'm going to work off of, and here I can see, well, the 10.2 is my opposite side, and x is my adjacent side. Opposite and adjacent, I can see t for tangent. So as I set that up, the tangent of 15 degrees is equal to, and we have to be careful of our order, it is the opposite over the adjacent. Now this one looks a little bit different because as I set up my proportion here, and I look at my cross products, I can see we're going to have 10.2 equal to x times the tangent of 15 degrees. And that's okay. We're still solving for x. X is being multiplied by tangent to 15. So we're going to go ahead and we're going to divide by tangent to 15. But what I do on one side, I need to do on the other. And so 10.2 divided by tangent of 15 is equal to x. We're going to go ahead and calculate that. 10.2 divided by tangent of 15. And we would find that x is about 38.07. Now again, you can calculate these using your phone. You just need to be careful because the way you enter it is a little bit different. To get my trig functions, I need to make sure I have my phone tipped horizontally. If I need 10.2 divided by the tangent of 15, here I would put 15 tangent, and then I would hit enter, and I end up with 38.07. Okay, if you have further questions on this, please stop in to see me.